Okay, so now I think we have the audio. Hello and welcome. Let me put the music down. Turn down the volume a little. And I think we are good to start. And let me do this. Okay, so hello and welcome to RepRapper's live show. As every Friday, we are here. We are going to today. We are going to talk about what? About how to slice, right? For FDM 3D printer. And as you know, we every Friday do these live shows to share with you some useful information, some training about 3D printing. I am Jay from RepRapper Technical Department, and here my colleague is Echo from RepRapper's e-commerce department, right? Yeah. So now, before we start, my colleague is going to do a brief introduction of our company.
Yes, our company named RepRapper was founded in 2012 with the aim to producing the high quality plastic filaments for the printer, 3D printer that was starting popular at the time. You know, maybe in 10 years ago, the 3D printer became popular.
Yes, it started maybe in 2010, 2012.
Yes, and our company name RepRapper came from the RepRapper project, movement that aim to create the open source 3D printers.
Hello, William.
Yes, so maybe for that, maybe they want that all the family could have 3D printers. That maybe at that time we can print some tools or something else at home. So maybe we can save money or reduce the pollution, I think.
Yes. Some good objectives. You know?
Yes. So, okay. Yeah. At the beginning, we just have the plastic filaments, but now we only have the resin.
Yes. Now we produce resin and a lot of different filaments. In fact, we produce a lot of different materials, but normally in Amazon, we only sell the most commercial ones. Those normally, yes, are meant to be used in the domestic 3D printer. But yes, in fact, yesterday I've been preparing the catalog, and we have like a lot of very special filaments like PEI, right? PEI, and this PEEK, you know.
Peak, yeah.
But that thing is very expensive, very difficult to print.
And I think the normal printer can print it.
Yeah. Yes. And we are going to talk about how to slice for 3D, for your FDM 3D printer. Yes, but I want to show you, because we got ourselves some nice Christmas backgrounds.
Yes.
We have been playing with
Christmas is coming. Yeah.
Christmas is coming, guys. You know, this is the most beautiful moment of the year, maybe.
Yes.
I don't know. Here, my friend asked if the Christmas is like the Chinese New Year. I think it's very similar, because in Christmas, you know, we get together with the family. It's the moment of the year when everybody goes back to their hometown maybe. So
yes, we are the same.
It's
Yeah.
the same like the Chinese New Year, and also we always have this decoration and a lot of light. So yes, I prepared this background for you. Yes, this look, it's snowing. We have heavier snow, right?
Yeah.
It's awesome. But I think this background makes me feel cold, you know.
Yes.
My friend prefers this one, you know.
Yeah, this one.
It's
Just
also
like at
very
home,
Christmas. Very Christmas. We have here this nice, you know, this the fire, right?
Yes.
Fireplace. Very nice. Okay, so let's start. We are going to talk about how to slice, right, for the 3D printer. So probably we should start explaining what is to slice, right? You know, well, we know that the 3D printer basically prints the objects layer by layer,
Yes.
right? So what the in some way is like, you know, cutting, making slices of the object. So the slicer is the software that is going to allow us to take a 3D model and cut it in slices, cut it in layers, and each of that layers is the ones that are going to be printed by the 3D printer, right? Maybe we can use some nice picture to show you better what I'm talking about. Here, what is a slicer? Okay, so we can see the slicer as this, right? Something
Yes.
that takes something that takes a 3D model and cut it in slices, as I mentioned, right? Here we have another nice picture showing that, you know. So we have the STL, and the slicer is going to cut it in layers, and the 3D printer is going to print each of those layers. Another way to see the slicer is like a software that is going to transform our STL file into a G-code file. Okay. A G-code file. Okay. So the STL file is something like this. Okay. The STL file is a document that is going to contain the geometry of the object, and the geometry is defined by like a set of points in the space. So connecting like those. Well, in fact, I think they use like something like triangles, but I mean, it's a representation of the object in a three-dimensional space. You can see, for example, in these pictures that it's just a lot of points. So what happens if we have more points? If we have more points, we are going to have a more detailed object, right? But also, the file is going to be bigger, right?
Yes.
Because it contains more information. So, okay, STL file. So this is a STL file, okay, and a G-code file is what the printer is going to read, and it's going to contain the instructions or about how the printer needs to move, right? So a G-code file is just, as I'm going to show you, Tile3 and not S3D is that product, not yet product. But we are going to show Cura.
Yes.
Not Simplify 3D. Yes, Simplify 3D we use for our internal, you know, internal purposes. Honestly, because we are too lazy to learn how to use another one, right? So for us it works. It's good. Okay, this is the, you know, as I was explaining, what a G-code file. Specifically this part. So you can see a G-code file is basically a list of instructions. Each of these line is one command that we are sending to the printer. For example, all of these commands that you can see is G1, and then we have X and a number, and Y and a number, and E and a number. This is telling the printer to move. Okay, so in each of these commands, we are telling the printer, okay, move your X-axis, move to this position, move the Y-axis to this position, and the E is for the extruder, so extrude some filament. Most of the commands in the G-code file are going to be movement commands, but also, for example, when the printer starts working, there are some commands like these ones that are going to maybe set up the temperature. So we can see here this M140, M190. These commands are going to set the temperature of our heated bed and the temperature of our hot end. And yes, in fact, there are a lot of different G codes, and I have here prepared, because in this website, the Marlin website, we can find the complete list of all the G codes that, well, not all these G codes are available in our printers, but these are like the G codes that are like designed, you know, and they are in the firmware. So of course, to execute some of these G codes, you are going to need some specific hardware, right? It's like this one, set chamber temperature, M141. So of course, if your printer doesn't have the chamber, this G code is useless for you, but it's here anyway. And it's interesting because, for example, if we want to see, you know, how a G code, a particular G code works, we can go through this list and we can find a very nice description of what the G code does, and maybe, yes, some use examples. It's interesting, and it's maybe a little advanced, but it's very useful to know how this works. Okay, so yes, the slicer is going to transform the STL file, for example, we have here some nice STLs I can open directly. I don't know what software is going to use. Okay. So this is the STL file, right? This is the object, and after being sliced, what we are going to have is something like this, just a list of instructions. Okay, so next thing we want to talk about is, I think, is like, you know, because there are a lot of different slicers available, and for example here our friend William mentioned that we should not, or maybe he recommends us not to talk about Simplify 3D because it's a dead product. Yes, in fact, there are a lot of different options nowadays about slicers. Just let me show you in this nice article. Let me ensure that, okay, yes, the sound is good. You can see in this article we have a list here of maybe, I don't know, 20 different slicers. We have a lot of options. So what is the best slicer, right? Or what, how to choose the best slicer for us? Well, I think all of them are similar. I mean, of course, all of them are slicers, so they serve the same purpose. The main differences maybe are going to be in terms of the user interface. Okay, so maybe some of them have, you know, the workflow inside the slicer, and the user interface is going to be different. And despite all the slicers have also almost the same options, normally each slicer maybe is better. It's particularly good to do something in particular. So for example, Cura. Cura, we know that is very good to create these 3 supports, right?
Yeah, 3
so
support.
if we want to do 3 supports, probably it's a good idea just to use the Cura. And for example, what I have here, Simplify 3D, the dead software. Simplify 3D is powerful when it comes to idea maker. Okay, yes, I need to take a look of that. Maybe William can let us know what what is the the feature that makes idea maker especially good. Because for example, Simplify. What we like about Simplify is that it allows us to prepare sequential printing print jobs. That means that we can print during the same print job, we can print maybe the same object 5 times, applying different parameters to different settings to each object, and that is very powerful when you are testing materials. That is something we do here, right? So if you want to test a filament, you want to do the same print job a lot of times with different settings, and yes, it helps us to save a lot of time. And for example, we have this something like the Kiss Slicer, I think. Kiss Slicer is especially good because it's very lightweight. That means that maybe you can run this software in computers that are not very powerful, and maybe the interface is like very very simple. I don't know, honestly, I didn't use Kiss Slicer. I'm just telling you what I read about. Okay, but for our lesson we use the Cura, right? We use Cura, and we use it because we have a list of nice advantages. First one is free, right? That's good, right? Free is good, and it's open source. Open source, means that the code of the software is public, so anybody can maybe add some feature or modify something, maybe even adapt it for your company. Also, it's available for all the platforms, and that is, for me, is very important. You can run Cura in Windows, Linux, Mac, maybe even something like in a Raspberry, something like that. I think it's based on Java, so it should be very, very portable. Okay, and it's in continuous development, so that means that they are always adding. I need to change to my nice Christmas background. It's in continuous development, so they are always adding new functionality and that kind of things, and they have a big community. It's backed by a big company, which is Ultimaker, and I think also it's very powerful, right? I mean, it has a lot of options, maybe too many options, but it's okay. And yes, so that's how you choose your slicer. I don't know if we really answer that question, but okay. So now we are going to show you how to slice. Okay, that's the purpose of this live show. And to do that, you're going to open our Cura here. Idea Maker offers fantastic support. The custom texture to your prints. For double extruder printers. Wow, this is okay, William. I will definitely take a look of this slicer, and maybe the next time we can use it. And it's also free. If it's free, I think it has everything we like about something. If it's not free, I mean, if we need to pay something, we can pay. We are not that,
Yes. It's okay.
It's okay. It's okay. It's okay. Of course. Okay. But today we are going to do free. Yes. Nice. Thank you, friend. I will definitely take a look of that. I like the option for the custom texture of the print. In fact, I remember something called velocity printing. that is a feature, I think is probably in the Prusa slicer and in the software Prusa slicer forked from, and that allows you to create a texture on the surface of your part by modifying the print speed. So if you are printing something like a base, for example, maybe different regions of the model can look different because the printer is going to print faster. It's called velocity printing. It's a nice technique.
Okay, cool.
Okay, let me screen. Okay, the Cura. Okay, so we are going to use Cura today to talk about how to slice. In fact, all the slicers, I think they are similar. You are going to have something like this, which is a representation of your 3D printer. And first, you are going to place the models in this space, and then we need to select the printing settings, right? But before doing that, also in every slicer we need to define our printing environment, and that means that we need to tell the slicer what 3D printer are we using. So let me show you, for example, in the Cura, we do that by adding a printer here, and okay, so you can see we have a list of printers, but we don't like this. What we want to do, is to add a custom printer. So let me find, yes, here, the custom. Smoothie custom? I don't know what it is. Custom printer, okay? So here we need to specify the characteristics of our printer, especially the printing area, right? Maybe something like this, depending on the printer, 220, 220, I don't know, 250. Yes, some printers, they use the circular build and bed, elliptic. Normally, I mean, most of them. Hello there, Chris Angel. Hello, friend. Where are you from? Maybe you are from France? That's nice. Some printers use the circular build plate, right? But normally it's rectangular. And what is important is about the extruder. It's very important to set up the nozzle size and the size of the filament, because this is going to determine how many plastic volume we extrude, the nozzle size and the filament diameter. Okay, so be sure to have these settings right. After selecting this, you will have something like this, right? A representation of your 3D printer, and we can start adding something. We can add some models. For example, let's start with something simple. What do we have here? Laptop man.
Laptop man.
Yes,
your favorite.
This guy. Yes. I like this guy because it's a very nice model. I think it's nice. It's very detailed, and also it's very challenging to print. This guy. Okay, so we place the object, and then before going to the printing settings, we need to decide the scale of the model and the orientation of the model. That is more important. We can scale up and scale down our objects to make them bigger. No problem about that. Of course, if we print something bigger, it's going to take more time to print, right? That's obvious. And also, it's going to use more filament. That is also obvious. But normally we can scale at our, it's up to us. We can scale, and the part is just going to be bigger. There are some models that we cannot freely scale up or down because they are designed to have like some particular scale. For example, I don't have here, but those models, those printing place models, for example, that are designed with some specific tolerances, like the hinges, or maybe some gears, something like that. In that kind of models, if we scale them down, the model probably is not going to be able to move. And if we scale them up, maybe the tolerances are going to be lost. So, scale at your, how do you say in English? I mean, you can scale up, but take into account that some models you cannot scale freely. Okay, what is more important for the print is the orientation of the part. I mean, we can do something like this. Rotate the object, choose different positions, right? The thing is, the orientation normally is going to have an impact on the supports, because normally we need sometimes we need to place supports in our print jobs. So ideally we should choose the orientation that allow us to print the object without using any supports. Oh, sorry, I need to change here. Yes, so we were talking about orientation, rotation of the part, and supports. Let me show you very fast what a support is. I'm talking about this. You know that in 3D printing, because this is a layer by layer process, the upper layers needs to be supported by the layers below, and depending what are we printing, there is nothing to support. This is the good example about the letters. So this letter, the letter Y, we can print, it's okay, because all the upper layers are supported. But if we print this H, the central section is not supported by nothing.
Yeah.
So in some parts we are going to need supports. So ideally, let me Mega Man. If we can find an orientation for our part, for our model that allows it to be printed without any supports, that is normally like the best orientation and the right orientation. But sometimes, like for example printing this model, yes, now I'm back. Yes, for resin printer, I think I want to print the laptop man. In fact, I have all the collection. Other day I will share with you. If we want to print the Mega Man, there is no matter what orientation we use, we are always going to need supports in some place. You can see that the Cura is going to use the red color to show us the regions of the model that needs to be supported. And in fact, if we change the orientation, we can see how the red parts are changing and moving from one place to another. But there is no orientation that allows to print this without any supports. So in this situation, we need to decide what side of the part we consider is more important for us, because of course the supports are going to leave some defect, some imperfection in the regions of the model where the model is supported. So, for example, for Mega Man, I'm not saying that is the best orientation, but if we decide that for example, we don't want support in the face of the model or in this arm here, because we consider this is like the point of view that we want for our model, maybe we can print like this, so the supports go to the back. And in fact, well, is what we did to print Mega Man. You can see this model is very nice, and we consider that the face and the arm is the most important for us, and we place the supports here in the back. So the back does, it has this rough finish because this part, this region of the model was supported. Maybe I can even show you one something here. Cooling temperatures. I don't know if I have this here. Okay, it's not important. It's not important. So this is about the orientation, right? Try to find the orientation that don't require supports or, yes, what we mentioned. And now after deciding the orientation of the model is when we go to the print. Wow, this guy again? No. Is where we Calicut, yes, I want to use this one. Is when we can start deciding our printing settings. But I want to mention something that I think is very, very useful, very obvious maybe, but for me it's probably the best piece of advice I can give you, and is that you don't need maybe to think a lot about how to slice the part. The best thing you can do is when you download the model. When you download the model, for example, you see this, the Sagrada Familia. This model is very nice. You can guess it's very difficult to print or it's complicated. So if you want to print this, first take a detailed look of the description of the all the information that is published with the STL, because normally the author is going to give us some very good tips on how to print successfully the STL. So for example, if we go here, we can see that they recommend us, yes, use supports, use this infill, use this resolution. He recommends us scale up the model, to 2500, in the same way, we can find useful information in the comments. So I really recommend you go through the comments, and also you can take a look of the makes of other people, because they are going to give you some tip about the orientation, and also the makes also contain further instructions. So that's my advice, right? No, don't try to reinvent the wheel. Just try to do a little research on how other people is printing the object. Okay, so now is when we are going to start slicing this. I'm going to use this guy, the Calicut, because of course if the model is simpler, the software is going to need less resources to process the file. So for this presentation is faster to use something like this. Okay, so we decided that we want to print this in this orientation, so we can click where? Here in slice. What is the printing settings? Here. Yeah. Here. Okay. So this panel is going to give us all the printing settings. In the case of the Cura, what Cura does is you see each setting is classified as basic, advanced, or expert. So if we select here basic, you can see for each of these set of settings, we only have a few options to choose. But if we select the advanced, you can see how these menus start populating with more options. And if we go to the all settings, we have like a crazy, you know, we can select a lot of things. Most of them are useless, maybe not useless, but at least not relevant. We are going to go just with the basic settings because in fact this presentation is like a basic introduction to slicing. The first option, and probably the most important within field, is the layer height. Okay, what is this? We already said the printer is going to print layer by layer, and the layer height is going to tell the printer how thick we want each layer to be. What's the impact? I mean, what impact does this have in the print job? Of course, if the layer height is very small, the object is going to have more layers, and that means that the surface of the object is going to be better defined. It's going to have more resolution. In the other hand, more layers are going to need more time to print. Right? So I can show you with this part. The problem with this part is not very detailed, but yes. For example, we have the calicut. Imagine I'm going to use a ridiculous layer height of 1 millimeter, right? So I slice to 1 millimeter, and the result is this. You can see. Well, maybe I will use even a more ridiculous print layer height of 2 millimeters. Okay, so you see, the object is going to have 33 layers of plastic, and it's going to print very fast. In fact, it's going to print in only 21 minutes because it only has 33 layers. What's the problem? The problem is that you can see the layers are so thick that, you know, this doesn't, you know, this is not a line anymore. This is just like a lot of steps.
Yes.
It's not defined. And
I agree. Yeah.
In fact, in this object, maybe it makes not a lot of difference because this is just like a very simple model. But you know, if we do the same with something like what do we have here that we can show? If the model has a very detailed surface, the bigger layers really are going to make the model have less quality. Maybe we should use the laptop man. Let me laptop man a little. Okay. Yes. Let me go back to the laptop man. And okay, so we have this guy, and we are going to see what happens if we slice this guy with a ridiculously big layer height. What is the settings? Where are the settings? Here. Okay. Okay. So laptop man.
Ow.
Yes, 2 millimeters layer height, so you can see what we have here. It almost is almost unrecognizable, right? We don't know who is this guy anymore, right? The detail in the face is gone, but it's going to print very fast, only 38 minutes, because in fact it only has 75 layers, right? In contrast, what happens if we use a layer height of 0.1 millimeters? Let's see. You can see the software needs more time to do this. Okay. So you can see now, at 0.1 millimeters, the layers are so small that we almost cannot see the layers, right?
Yes.
And you can see how now the face is super well detailed and very defined. And yes, the quality of the object is very good, is very high. But what happens here? Maybe I need to move. You can see what happens. Now the part, instead 38 minutes, now it needs almost 8 hours to print.
Yes, with more time.
And instead, how many? Yeah, previously it had 75 layers. Now it has 1,400 layers. So that's why the layer height is so relevant, right? It's going to impact the quality and the printing time, and those are very important settings. Okay, I put this here again. So, what are like adequate layer heights? Normally, for this depends on the nozzle, you know.
Okay, so what's the layer height we usually use? You think it's the best?
It depends on the
for
nozzle.
normal, I think.
For example, in fact, we did the experiment of slicing 2 millimeters, but with the 0.4 nozzle, we cannot print at 2 millimeters layer height.
Yes.
In fact, you can see the Cura is giving us a warning here. It's telling us the layer height is too big. I think they say that the maximum layer height is maybe is of course never bigger than the nozzle size.
Never bigger than nozzle size.
I think it's maybe like 75% of the nozzle size.
Okay.
So for 0.4 nozzle, normally you can print the maximum layer height maybe 0.3, and well, the minimum is not defined by the nozzle. But normally with the 0.4 nozzle, we print between 0.1 and 0.3 layer height.
Okay.
So what we do is, if we want, if we are not, we don't care about the quality, we can use 0.3 millimeters. For example, for a functional part, which surface it doesn't have a lot of detail, we can use 0.3. If like the general purpose layer height, I think 0.2 is the right one, because 0.2 is going to give us a very, I think all of this is printed at 0.2, all these objects we have here. 0.2 is going to give us a very nice surface quality, and 0.1 is only maybe for parts that are very small, so we want a lot of detail, or parts that for some reason, you know, they have a lot of detail. But normally you are going to print at 0.2 layer height, and it's very good.
Okay. So this one is the.
Oh, let me show you what is here. I have some pictures here. Maybe. As you can see, the difference between layer heights, tall layer height versus short layer height. So I think we already explained well this. Let's go back to Cura, and let's go back to my Calicut. Okay. So the next settings we want to talk about is, you know, related to you know, the consistency and the infill of the part. These are the walls and the infill. The walls and the top of the bottom are part of the same. I mean, it's like the cells of the objects. the walls are like the horizontal cell of the object, and the top at the bottom is like the vertical cells. So basically, to show you how this works, I'm going to, and of course the infill is the inner part of the object. So for example, we can set the infill to 0, and let's slice this and let's see what happens. Okay, so now
empty inside.
we have an empty print, empty model. This is going to print something empty. So if we increase the wall thickness, for example, now is 0.8. If we use something like 4 millimeters here, and we slice again, we can see, how these walls now are bigger. This is going to have an impact on the strength of the part. Of course, if the cell is thicker, the part is going to be stronger. Also, it's going to take, it's going to require more time to print, because we have to print all of these cells, and also it's going to require more plastic. We are going to spend more material. The top and the bottom is just the same. Here we can see now we only have 2 bottom layers. We only have how many layers? 3 bottom layers. So at the beginning you can see we have 1, 2, 3, and the model starts to be hollow. If we increase this and we set here something like 10, now we can see. Maybe it's not very easy to see. Maybe it's easier to see with the upper layers. For example, imagine that we set the top layers to 0 and we slice. That means that in the upper regions of the model is going to have nothing, We don't have any lid, something here, because we don't have top layers. If we place here a very high value, like 20, here it starts printing the top layers. Yes. And the infill is going to be everything that is not the cell, right? Now it's empty. If we set something like 10%, you see now we have some structure inside. For the infill, we can set the percentage of infill and also the infill pattern. We have different kind of patterns. For example, we have the E01 one. You know the E01 one? Maybe this is something from Cura.
Wow.
This kind of infill. Yes, I can show you the picture. Maybe it's easier. The infills. Well, this is a picture about how different degrees of infill, makes the part look like tougher, right? And these are different infill patterns that some of them are just decorative, but some of others, they all have some impact on the print. For example, this kind of infill, this is the honeycomb. This is supposed to be very strong because, yes, this kind of structure is like very, very strong. It doesn't like deform. I'm not an expert, but I think it's good. And some of these, like the wiggle one, some of these infills maybe will give us more strength in some direction than in other direction. So yes, depending of the purpose of our project, we can we may want to take a look of the different infields available. Okay. The next thing we set is the printing temperatures. Printing temperatures basically is the temperature for the hot end and the temperature for the heated bed. Okay, so this value normally is going to be given by our filament supplier. For PLA, we know the printing temperature is between 180 and maybe 210, something like that. The printing temperature, depending, for example, I mean, from one printer to another, the optimal printing temperature can be different, because if depending how the printer is built, maybe the reading of the thermistor is not exactly the same. So maybe two different printers, maybe both we set the printer to 190 degrees, but maybe in the first printer the real temperature is 200, and in the second one maybe the real temperature is 185. I don't know. I mean, there are some differences.
So in the beginning we must test.
Yes. So for that reason, for the printing temperatures, the supplier normally gives a range. They don't give you 184. No, they give you between this, and that's because there can be some differences. The optimal way to find the best printing temperature is to print a temperature tower. A temperature tower, yes,
something like that.
Is this kind of thing. So this kind of model is designed to print. You can see it's a tower because it has a lot of different floors, right? And all the floors are the same, but the idea is that we print each floor with different settings and different temperature. So this can help us to find what is the temperature that delivers the best quality for us. For example, in this one, you can see maybe a 180 looks terrible, looks like very bad, right? But you can see, these temperatures above